At State of Unreal 2026 and Unreal Fest Seoul 2026, Epic presented Unreal Engine 6 as a merged Unreal Engine 5 and Fortnite runtime built around verse, scene graph, and a transactional runtime. I'm going to break down what I think actually matters here, so let's get into it. I'm with MonsterPixel Labs. If you're new here, we break down what's actually happening in Unreal Engine and gaming tech. Anyway, back to it. Before this, the core of Unreal gameplay was C++ actors and blueprints. Actors held components, and blueprints wired behavior. That was enough for a lot of games, but persistent worlds made it hurt. If two players touched the same object, someone had to decide who won. If a player's save state needed to move, someone had to serialize it, ship it, and rehydrate it. If a server got crowded, someone had to design ownership, migration, and conflict rules. Epic said Fortnite has 80 million monthly users, and that scale is exactly where this plumbing gets expensive. That's not a hypothetical. Epic said if they had 1,000 players, they wouldn't have been able to do it. And that line lands because Fortnite is the production pressure test for this architecture. Now, 1,000 players is a small number compared with Fortnite's 80 million monthly users, but it's enough to break a lot of hand-built save and replication code. I think the old model is best explained as a renderer plus a scripting layer. The engine draws the world and gameplay code mutates objects. That works until the objects become shared, persistent, and distributed. Now the problem stops being how do I make this look good and starts being how do I make this state stay true across machines? And that's a different job. Verse is the programming layer Epic is putting on top, and it's aimed at state and behavior rather than pixels. It's a language and object model where engine systems and gameplay behavior are expressed as verse objects. Epic described Verse as a next-generation programming language purpose-built for massive, persistent game worlds. Verse was originally released 3 years ago in Unreal Editor for Fortnite, so this isn't a brand new idea dropped on a stage. It's a language that already lived inside Fortnite custom games, and now Epic is making it the foundation of Unreal Engine 6, and that gives the language a real production history before it becomes the engine foundation. Scene graph is the composition layer. Epic described it as a modern component framework with prefab-style workflows and composition. I read that as a move away from the old actor as a monolithic container. Instead, a game object becomes a graph of connected pieces. A weapon can be a verse object with components for damage, animation, network state, and save state. A vehicle can be assembled from smaller systems, and a designer can reuse those systems across games. That's the part that makes portable content more than a slogan. But it's not just a parent-child transform tree. Epic's description treats it as a component framework where objects can be composed, reused, and reattached. And that matters because a migrated object needs to land in a new scene without rewriting the whole actor. Now the part I found most interesting is the runtime. Epic said verse functions execute inside atomic transitions. That means a gameplay action is treated as one all-or-nothing operation. The runtime starts a transaction, tracks the state it reads and changes, and then commits or rolls back. If the action succeeds, the changes stick. If it conflicts, the runtime undoes the partial changes and can try again. In plain terms, the runtime is trying to turn a multiplayer race condition into a managed retry. The developer writes the action once. The runtime handles the attempt, the conflict check, and the rollback. I think that's the core idea. And it's a different way of thinking about concurrency than adding more locks around shared variables. Here's the concrete example Epic used. A moving object is moved, a spatial query is performed, and a collision occurs. In that case, the entire transaction is canceled as if the code never executed. That's a simple local case. The bigger case is distributed. If the object is on another server, the runtime can roll back the transaction, migrate the object between servers, and automatically execute the transaction again while maintaining simulation consistency. Let's walk through a shared pickup. Two players try to claim the same item. Player A's pickup is a verse function on the item. The runtime starts a transaction, reads the current owner, and writes player A as owner. At the same time, player B's transaction reads the same owner field and attempts a conflicting write. The runtime detects the conflict, rolls back one transaction, and re-executes it against the committed state. So only one owner is valid, and if that item later migrates to another server, the runtime carries the item's verse state, reattaches it in the new scene graph, and can re-execute the pickup transaction there. This is where the analogy helps. It's like a bank transfer that's all or nothing. You either move the money or you don't. But game state isn't a ledger entry. It has time, physics, animation, and player-visible consequences. So a rollback isn't just reversing a number. It has to preserve simulation order. That's the hard part. I'm not sure how much of that cost is visible to a developer. The sources don't publish performance numbers for rollback, migration, or re-execution. They don't say what a failed transaction costs in milliseconds, or what it costs in memory, or which systems still need manual handling. That's a real gap. Epic said the runtime can synchronize and save entire game instance states, and that persistent player data could be defined as a global map connecting a player and their save state. That sounds like it could reduce separate database and back-end coordination for certain data. But I'd watch the fine print, because a global map still needs rules for what counts as a conflict and what state migrates. But the engine still has to define what counts as a conflict. Does a failed spatial query count? Does a physics overlap count? Does an animation state mismatch count? I don't know yet, because the sources don't say. And that's exactly the kind of detail a production team would need. Now, the state of the thing, Unreal Engine 6 Early Access is targeted for late 2027. Unreal Engine 6.0 is expected 12 to 18 months after early access. Unreal Engine 5.9 is confirmed in development. Unreal Engine 6 development is active on a public GitHub mainstream branch. Fortnite development is included in that same stream. Unreal Editor for Fortnite was also migrated to Unreal Engine 6. Tim Sweeney said Epic's plan is to bring Fortnite, Unreal Editor for Fortnite, and Unreal Engine technologies together and merge them into one, rather than keeping them as completely separate products forever. Now, the architecture is layered. Existing Unreal Engine systems such as rendering, chaos physics, and animation sit at the bottom. Scene Graph sits above that. Verse sits above that. A new gameplay framework sits above that. Games and content sit on top. Epic describes Scene Graph as the central system or core of Unreal Engine 6, capable of representing and managing three-dimensional objects, items, quests, and other gameplay systems. Verse can expose materials, meshes, sounds, and components as verse objects. More complex systems such as characters, weapons, and vehicles can be packaged into reusable systems that work across multiple games. And that changes the unit of reuse. In the old model, a studio might import a vehicle mesh and animations, then rebuild the gameplay logic. In the new model, Epic is describing a functional object, including content, components, and gameplay logic. Fortnite cosmetics will be the first proof point. Epic said Fortnite cosmetics will become an open Unreal Engine 6 module usable by all games, and that entitled Fortnite outfits can be used in other games while custom outfits can work in Fortnite. And that's the first concrete test of whether portable content can survive outside the original game. Blueprints are on a deprecation path. Epic said blueprints will remain in early Unreal Engine 6 versions, but will eventually be removed and replaced by verse code. One breakdown estimates removal in about 5 years. That's a long runway, but it's still a real migration question. The community concern goes beyond learning a new language, because verse isn't beginner-friendly as a first programming language, and Epic may not replace blueprints with a better visual node-based scripting workflow. That matters because blueprints helped a lot of people enter Unreal. If verse becomes the only path, the onboarding shape changes. What isn't confirmed is just as important. Epic hasn't published a stable Unreal Engine 6.0 date beyond the 12 to 18-month window. Epic hasn't published performance numbers for the transactional runtime. Epic hasn't defined the exact verse syntax, the full interface surface, or which engine functions are exposed as verse objects. Epic hasn't said which Unreal Engine 5 C++ systems, plugin interfaces, or platform targets will be unavailable or changed. Epic hasn't confirmed whether Unreal Engine 6 will require new hardware or support all existing Unreal Engine 5 platforms. Epic also described verse as the programming foundation, alongside the low-level C++ engine. The sources don't say C++ disappears. And that's an important distinction, because a lot of Unreal's core systems still live in C++. The upgrade path is expected to be similar to the Unreal Engine 4 to Unreal Engine 5 move, but that's an inference, not a published guarantee. But I think the honest read is that Unreal Engine 6 is moving the engine from a tool for building scenes into a runtime for operating persistent state. The renderer is still there, the animation and physics are still there, but the new center of gravity is composition, state, and consistency. And that's a bigger architectural change than a new lighting mode or a new geometry system. So where does it stand? Epic has given a timeline, a public branch, and a real production test bed in Fortnite. So the mechanism is described clearly enough to understand. Verse objects, scene graph composition, atomic transitions, rollback, migration, and re-execution. The open question I want answered next is what happens when a transaction fails in a live world with real latency, real physics, and real players watching. And I'd want to see a public demo where a transaction fails under real network latency, not just in a clean editor test. That's where the claim either becomes boring or becomes the hard part. That's the part I'll be watching. Plenty of channels will cover every announcement and tell you each one changes everything. That's not what I'm trying to do here. I'm trying to take one thing a week and actually explain it properly, so you come away understanding it. If that's something that sounds interesting to you, consider liking this video and subscribing to the channel. That'll make sure more stuff like this shows up in your feed. Anyway, that's the one for today. See you in the next one.